class a lot louder because I had the music bumping. Good old Paw Patrol. Okay, so section 3.2, which is on averages. So this might be a review for a lot of you guys. These are important things, but it might just be something you need to brush up on. So we're starting a new section. I don't have your exams graded yet. I'm still working on that. I've got a little bit of a backlog. But I'm hoping I can get them back to you guys on Thursday before the spring break. I'm gonna do everything in my power to get them back to you by then. Anyways, we're starting up a new material. So good news is, like, if you didn't like last material, we're going into a completely different area. And so to set up this problem, I'm gonna use a data set example. The data set that we're going to follow along with is curly brace 15, 32, 15, 42, 100, and 27. That's going to be our data set. So this is there's a thing that bugs me like as a mathematician when I see people say the average, because there are actually three types of average. There is number one, which is the most commonly used term for average, which is the mean. And the way we calculate this is you add up all data entries and divide by the number of entries in the set. This is what most people refer to when they say average. Like if you hear like those if you have a child, they say like that they're like the average height of a 2-year-old is blank 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 or whatever, like 32.6 inches or whatever. That's taking every single data value that they have, every data entry for all the heights that they've measured for all their children, their toddlers around the United States, and then they average them. They add them all up and divide by the total number that they have, and that's where they get the average height. And so in the example, what we do is we'd say the mean, which is sometimes written as mu, the Greek letter mu, which kind of looks like the combination of an M and a U at the same time. So if you want to see how I write it, you start at the bottom, you go like this. That's a mu. And then the reason why I mentioned that is we're going to talk about standard deviation, and that formula requires you using mu in it. And so the mean here would be, okay, 15 plus 32 plus 15 plus 42 plus 100 plus 27, all divided by 6, because there's 6 data entries. 1, 2, 3, 4, 5, 6. And if you do that, make sure if you're going to do this in your calculator, depending on your calculator, make sure that the numerator is in parentheses. Because if it's not in parentheses, it'll just divide the last number by 6. If you don't put this whole numerator in parentheses, it'll cause problems. But the way around that is you just compute the numerator, add them all up. You get 231 divided by 6, which ends up being 38.5. That is the mean average of the data set. So I would like it to say, like when we hear those things and on the news and things like that, they say the mean average or the median average. So then we know what they're talking about. And the reason I say that is there's an important note about the mean. is that, and this is a fact that won't be tested upon, but it is an important fact for you to know about the mean, is that the mean is heavily influenced by outliers. I've got an example later in this in our notes that has to do with exactly this, but suffice it to say, if you have a data set and everyone's really, really close together, if all the data values are really, really close together and you have one data set off in nowhere in comparison, the mean will get very, very skewed because of that. So an example of this is when I plug in grades on my exams, because the Canvas does does the average based on the mean. And sometimes I have students that don't show up for the exams. Either just a mock student that's trying, like, apparently there's been issues with students trying to abuse financial aid, whatever, blah, blah, blah. But anyways, I have to plug in zeros for those people because it doesn't enter as a zero at first. And so I'll put in all the scores, and my average, my mean average on my exam will be like a 71. And then I put in those zeros, and my average now, since everyone was kind of like around the 60 to an 80 mark, but I put in those zeros, it drastically reduces it. So from being a 71, sometimes it'll drop down to like a 65. And that looks way worse. And students get understandably upset. They're like, the teacher, the average on their exam was a 65, or like everyone was failing. I'm like, no, you guys actually had an average of a 71. It was just that there were several students that I had to enter zeros for, and a zero is a very, very, very bad score. It's all the way at the end. So it completely skews the data. There's a great example a little bit later. The next one is the median. This is the quote unquote middle number of a data set. When should be underlined? When the data entries, when the entries are lined up from smallest to largest, are arranged from smallest to largest. So the middle number when you arrange them from smallest to largest. If you have them all jumbled around, then it's impossible to find the middle number. But if you rearrange them, if they're already arranged from smallest to largest, awesome. But if they're not, you need to rearrange them. And then here's the issue though. A data set can either have an even number of data values or an odd number of data values, right? You'll have like, you got 10 people, you got even. You got 11 people, you got odd. If you have an odd number of data values, then there will be a direct middle number that's in the data set. But if you have an even number, then there's an even number on each side and there's nothing in the middle to be the middle number. So if two data values are in the middle, then we add them and divide by 2 to get the median. This happens when there is an even amount of data entries. So whenever you have an even number of data entries, that's when you'll have to take care of the 2 middle numbers. Now, the median is not affected by outliers. The median is actually a very, very good way of avoiding getting affected by outliers. And that's why whenever I try to present my averages, I'm so sorry. We're still working on that sleep. Still working on that thing. But where was I? The median is the way I usually present my averages to my class. If they ask for what the average is, I say then the median average was this, because that it allows you to, and you'll see this when we get to box plots. It allows you to really find the direct middle of the data values. So in the example, first rearrange. So we're going to have to rearrange the data set, because if you looked at it, the numbers were 15, 32, 15, 42, 100, and then 27. And that's not in sequential order. That's not from smallest to largest. So we just have to do that. And the reason why I rewrote them is that when you're doing this, luckily for us, we have our paper exams. And so all the numbers are there. But the problem with the online version is that you have to look at the screen, then down at your paper, then back at the screen. And there's a lot of chances to forget to get a number because they're so tiny. And you can't I don't know about you, I don't like touching my screen to verify. I don't like touching my screen. So sorry about that medium. That's why I recommend just jotting them down, make sure you have them all correct, because if you don't have them all listed, your median is going to be off. And then and your everything, your median, your mode, and your mean are all going to be messed up. So 15 is the first one I see, underline that, and then 15 there. The next largest number is 27. Got that. Next largest number is 32. The next largest number is 42, and then 100. So there's 6 data entries. And so you can, the original way to do it, that is great when you're working with small numbers, like 6 data entries, but when you're starting to work with like 500 or 200, something like that, it becomes a lot more tedious, is you've got to work inwards. So I'll work one in from the left and one in from the right. One in from the left, one in from the right. So there are 2 middle values. Two middle entries, which means that the median is equal to 27 plus 32 divided by 2, which is 59 divided by 2. Which is 28, 29, 29.5. So that's the median for this set. Now, that way of finding the median works in most situations, but it can become very, very tedious, especially, so this is just with 6 data values, but what if there were 15? What if there were 20? It kind of becomes a little more daunting to find the middle. And especially when we talk about frequency tables, which usually have way more than that. And honestly, it becomes far more tedious with frequency tables. So as a small aside, finding median quickly. So this is how you can find the median quickly if you follow this option. Step 1. Divide the total number of data entries by 2. The reason why we're going to divide by 2 is you're trying to find half the amount of data values. Divide the total number of data entries. So if there's 6 entries, divide by 2. Divide 6 by 2, and you will either get a whole number, quote unquote, n, or a decimal number, n.5. Sadly, we don't have time to go into the fun number theory about this, but when you're dividing by 2, your answer is either a whole number or it's a whole number 0.5. So you'll either get like 7 or 7.5 or 8 or 8.5, whatever. Whenever you divide by 2, it's either going to be a whole number or it's going to be a 0.5. So for example, with 6 data entries, you divide it, you get 3. That's a whole number. Whereas if there are 7 entries, you get 3.5, and so on and so forth. So step 2 is where we figure out what the median is. It's in 2 steps, or it's in 2 parts. If you get n, then the median comes from the nth and n plus 1th entry. This will look really confusing right now, and I promise you, once we see it in the examples, it'll start to make sense. And I'm going to do 2 examples underneath this. So if you get n, it means that you have an even, like, so I'll wait until I get the other one and then I'll explain. If you got n.5, then the n plus 1th term is the median. I know that looks like gibberish, at least for now. Kamori, for people, I can zoom out for a second and let you take pictures. Yeah. If you'd like to, you can come up to the board or whatever, take a picture, or you can wait until after class. I'm fine. Yeah, someone did they email? I don't know if they emailed just I think it might have been my no, office. Did everyone get an email from Office of Facilities and Management saying that there was going to be construction on Charleston or something like that, or that Charleston was going to be closed off? Maybe I'm mistaking it. Yeah, Oakley. It's great, Sahara. For this, if you get n, that means that it was an even number because it was divisible by 2. So like, for example, 6, when you divide it by 2, you get 3, you get a whole number. 8, when you divide it by 2, you get 4, you get a whole number. 200 divided by 2, you get 100, whole number. So when you have an even number of data values, you have 2 middle values. And so that's where you get the nth term. That's the nth and the n plus 1 will give you the middle values. Whereas if you get n.5, that will mean you have an odd number of data values. Like if you have 7 divided by 2, you get 3.5. If you have 9 data values, you get 4.5. 11 data values, 5.5, and so on and so forth. And that means if there's an odd number of data values, there's a direct middle in the center. And so it's just the next number in the set. So I'm going to show you the example here to figure this out. Example, find the median. Of part A. Someone give me some numbers. And it's between 1 and 100. 27, 58, 13. Let's get some other from someone else. 15, 9, and let's do 43. Perfect. And that is 1, 2, 3, 4, 5, 6. Let's do 2 more. 12. And let's do, I want to do one. I want to do it, which what my son says. My son, no, I want to. I let him open the garage door once. Now he has to open the garage door every time. Let's do 39. And then part B. So let's give some more numbers. Shout them out. Anybody? 8, 7, 15, 33. Let's do 78. Thank you for doing that one. 22. And then let's do one more. 56. Sorry, Sonia. Beach to it. All right. So we're going to find the medians of these data sets. And we're going to do it the fast way. Now, granted, once again, this is only 8 data values and 7 data values. It's not a lot. You can work inwards, but you can do it much faster this way. Oh, I should have arranged these in, well, gives us good practice. First rearrange. So for part A, it should go 9, 12, 13, 15, 27, 39, 43, and 58. See, do I have 1, 2, 3, 4, 5, 6, 7, 8? I got 8 numbers. I'm good. Okay. So this is how I figure it out, and to do it quickly. Number of data entries. So 8 divided by 2 is equal to 4. So that's my n value. That's my quote unquote n. So that means that the 4th and 5th give the median. So when you get a whole number, that's your n value. When you get a whole number, it means that the n and the n plus 1. So in this case, n was 4, so the 4th and the 5th. If n was 6, we get the 6th and the 7th. If n was 100, the 100 and the 101. So on and so forth. So looking at it, 1, 2, 3, 4, and 5. So these two. So the median will equal 15 plus 27 divided by 2, which will be 15 plus 27 divided by 2. You get 21. 21 is the median of that data set. Does that make sense? Granted, once again, you can do this the long way. It's just I wanted to find a faster way. And this is the way that I usually do it now. If I know I have an even number of data values, then I know it's going to be the middle 2. And that comes from dividing by 2 to find exactly half of the data set. And so on and so forth. So B, let's see here. So 7, then 8, then 15, then 22, then 33, then 56, and then 78. Should have 7 values. 1, 2, 3, 4, 5, 6, 7. Good. All right. So for here, the number of entries equals 7. So I take 7 and I divide it by 2, which would give me 3.5. So this is my n value. N is 3. So the n plus 1 is going to be the middle. So like basically, essentially, you're like rounding it up. So the fourth entry is the median. So 1, 2, 3, 4. So 22 is the median. So that's how it works. That's how the quick way works. You take the number of data entries, you divide it by 2. And then there's 2 situations. If you get a whole number, then that number and the next number in like the next entry, that entry and the next entry are the median. If you get a number 0.5, it'll be the next integer that is your middle. And I'm happy to explain why that works if you'd like to, but if you want to just memorize it or whatever, that's fine too. Does anybody want to like see more of an explanation as to why that works? It's okay. All right. So that was kind of like our little side. That's how you find the median quickly. So looking back at the previous example, if you look back at this one, there was 6 data entries. 6 divided by 2 is 3. The third and the fourth. The third and the fourth entry are the given median. So it works on every single one of them. So we'll go ahead and continue onward and talk about the next thing, the last type of average that's present. Number 3, which is the mode. This is the number that shows up the most. The number that shows up the most in the data set. i.e. has the largest frequency. Not like frequency Kenneth, right? Like for any of my REM fans out there. I don't know. Does anybody know who REM is? Wow, I'm getting older. My dad's favorite bands. As it's a band from a while back. Have you heard the song "Losing My Religion"? Is that ringing a bell? No. Everybody Hurts. Sometimes that one. That's REM. But not like they have a song called "What's the Frequency, Kenneth?" Not that frequency, not like frequency of radio waves and stuff like that, but frequency as in frequent. So the number that has the largest frequency. Now there's a couple things here. If the data set has 2 data values, has 2 numbers with the same largest frequency, we call the set bimodal. If there are more than that, there is no mode. So the mode should there is the option for a bimodal set. I'm never going to put that on an exam. It'll either be that there either is a mode or there's no mode. And so I'm not going to put bimodal on the exam. It might show up in your notes or in your homework, but very few and far between. Because it's just weird to talk about bimodal sets. The mode is probably the least useful of all the averages. It's more of a checking tool than anything else. It's like if you get a mode with a really large frequency, that's a cause for concern. So like, for example, if I was given a Scantron test to my students and I had like 30 out of my 60 students getting a 50 or something like that, that would be a very, very large mode, and that would be a cause for concern. Maybe something was wrong with the Scantron scanner. Maybe that was something wrong with like the questions. Maybe I entered the grading portion of it wrong, something like that. So mode, not super useful, but it is a form of fight. Oh God, I gotta wake up. A mode, it is a way of finding an average. So in our example, I'm going to rewrite the data set. It was 15, 32, 15, 42, 100, and then 27. So 15 is the only one with any frequency. Everything else has a frequency of 1. This is the only one that has a frequency that's not 1. So the mode is 15. Desperately need to wake up. So let's do an example of doing this all together now. Let's do 2 examples of finding all 3 pieces. Unless there's any questions on any of those. So the key takeaways that I want you to learn from this class, like outside of our class, like that won't be tested upon, but it's very important. Just like with unit conversions, how useful they are. The one thing that I really want you to know is that average, like the mean is heavily influenced by outliers. So this becomes very, very key when people talk about average income, average home price, like anything that involves money can be skewed greatly by outliers. If you have $1 million house and then a bunch of ones in the $200,000 ranges, they'll say that the average is like in the $400,000 range when it's actually much lower. Or like, and there's an example. I'm just getting ahead of myself. And then the other one is that the median is a far better representation of average when you have outliers. If you have outliers, use the median. If you don't have outliers, use the mean. When your data is very, very centralized, mean is the best representation. So let's do some examples. Find the 3 averages. Of part A will be, I'll let you write that down so we can write the numbers at the same time. It's hard to write down the number as I'm saying another number. Find the average, the 3 averages of 10, 33, 50, 50, 76, 81, 50, and 11. Once again, that's 10, 33, 50, 50, 76, 81, 50, and 11. And we're going to, by the way, we're going to round to tenths, which is 1 decimal spot. We're going to round to tenths. It's part A, and then part B. Everyone write that down. And by the way, so when it comes to exam time, so this is going to be one of the sections that's on the exam, so you can probably expect to see at least 1 question on averages on there, right? It's a section that's covered, so of course it's going to be on there. I promise you, I will always write my data sets in order, in ascending order. I don't want you to I don't want you to get the answer wrong just because you were looking at these really tiny numbers and getting it screwed up. this is something that I'm just doing for your homework assignments, because your homework will sometimes have them jumbled, but I can promise you on my exams, they will always be in ascending order. So that that you don't have to sit there and make that mistake, worry about making that mistake. Because most of our programs can do this for us now. They can, like, there's actually even like Excel has a formula to find the mean, median, and mode. But the more important thing that I like about Excel is it has the ability to sort. And so any program that requires you to do these things has a sorting function. So why bother doing this thing that's just meant to be a low blow? All right, and this set, ready, is 5, 5, 5, 5. That's it. There's only 5, and then 11, 12, 7, 15, and then 13. Once again, for the part B, it's 5, 5, 5, 5. So 4 5s, and then 11, 12, 7, 15, and 13. So part A, reorder. I want to be listening. I want to be watching a movie. Let's bring up Bill Nye. So 10, 11. Let's rearrange it. So 10, 11, 33, 50, 50, 50, 76, and 81. So once again, the numbers when they're rearranged to be 10, 11, 33, 50, 50, 50, 76, and then 81. So the mean average, all you need to do is just add up all the numbers and divide by the total number of entries. There are 8 entries total. Right? 1, 2, 3, 4, 5, 6, 7. Yeah, 8 entries. So that's going to help us with both the median and the mean. So for the mean, that's the number we're going to divide by. So for mean, 10 plus 11 plus 33 plus 50 plus 50 plus 50 plus 76 plus 81, all divided by 8. Then let's plug that in your calculator. I'm going to calculate the numerator first. 10 plus 11 plus 33 plus 50 plus 50 plus 50 plus 76 plus 81. It's 361. Yes. 361 divided by 8, which is 45.125. That's right, 45.125, but we're going to round to the nearest tenth. So approximately 45.1. So approximately 45.1. We're out to the nearest 10. Median, unless there's any questions on that. And so once again, this might be stuff that you've already seen before. If so, great. It might be a nice little refresher. And then after these 2 problems, we'll start doing. Then we might talk about something you haven't seen before, frequency tables. So median, the way I do it, there's 8 entries total. So 8 divided by 2 is 4, which means that the 4th and 5th entries give the median. I'm writing this for your notes aspect. If you like, you can do this in your head, or you can just write 4 and 5 or whatever you want, 4th and 5th. However you want to do it. You don't need to write all this in this notation, but this is. I used to want to do it, and so So 1, 2, 3, the fourth and the fifth entry are both 50s. So the median is 50 plus 50 divided by 2, which is 50. And then the mode is also 50 with a frequency of 3. Mode of 50 because there's 3 50s in there, and every other number only has a frequency of 1. All right. Any questions on that? All right. I'll rearrange the data set for the second one first, and then I'll let you guys calculate them while I slowly fill in the details. The reordered version of the set will be 5, 5, 5, 5, so 4 5s. Then 7, 11, 12, 13, and 15. So go ahead and find the mean, median, and mode. I'll slowly fill in details. I'm actually going to pause the well, so that people watching the recording don't have to like wait. All right, I have the answers up here if you'd like to check your work. So we're going to continue to do so. Oh, I forgot to box them in though. So for the mean, you take the number of numbers, you add up all the numbers, add up all the data entries and divide by the total number of data entries. So there's 9 data entries, so you do 5 plus 5 plus 5 plus 5, plus 7 plus 11, 12, 13, 15, and then divide by 9, you get 78 over 9, which is 8.6666 repeating or whatever, which approximates to 8.7 when we round to the nearest 10. For the median, there are 9 data values. So if you take 9 divided by 2, you get 4.5. And 4.5, like based on my little cheat sheet, that would mean that the next number, so the fifth entry is the median, should be 7. Though of course you can always do like the kind of moving your way inwards, and the same thing will work. It's just this works way better when we talk about frequency tables. That's the reason why I like to use it. And then the mode is just the number that appears the most. 5 with a frequency of 4. No other number had a frequency larger than 1, but if it did, it doesn't matter. You just need to choose the one that has the largest frequency. That's correct. So it like Lizette asks an excellent question. If these were all gone, then the answer would be no mode, because every single one of them has a frequency of 1. So there's no specific number that gets used more than another. All right. So any questions on that? All righty, then we will go ahead and do some little practice problems, word problems. So Phil has scored an 87, 88, and a 92 on the first 3 exams. What does Phil need to score on the 4th exam to have a mean average of 90. Round nearest whole number. So I gotta stop yawning. I'm sorry. I want to be the change in the world that I want to see. So I'm going to say mean average instead of saying to find a mean. Because I would like us to, as a society, I would like us to start quantifying it, saying the mean average of this or the median average. So that people start to recognize the importance of the two distinctions. So the mean average of a 90. So we have to ask ourselves, what are we trying to find? Well, we're trying to find the score on the fourth exam. We don't know it, so let's define it as an unknown variable. Since we don't know it, let's define it as a variable. Let x equal Phil's fourth exam score. Exam 4 score. We want the mean to equal 90. So we essentially just need to solve for x in the mean average formula. So we take all the 4 exam scores, 87 plus 88 plus 92 plus x, and divide that by 4, and that has to equal 90. Make sure you understand where that equation arose from. The mean is calculated by taking all the numbers that are present. So in this case, 88, 87, 92, and then your unknown exam score x, and dividing by the total number of data values, which in this case would be 4 because there's 4 exams, and that wants to be equal to that will equal the mean. But the mean was given to be, we want the mean to be 90. So solving this, there's a lot of different ways. I would recommend multiplying both sides by 4. But you could also cross multiply however you want to do it. And that cancels it on the left. And so we get 87 plus 88 plus 92 plus x is equal to 360. And we could subtract off 88 and subtract off 87 and 92 in 3 sequential steps. But it would be better to just combine the like terms. So that's 87 plus 88 plus 92 is 267. So we really have 267 plus x is equal to 360. And so in order to solve this, we need to isolate the x by itself. So we need to get rid of that 267. That's a positive 267. So we have to subtract 267 from both sides to cancel them out on the left and get that x is equal to 93. And since we define what x is, we don't need to say that he needs to score 93. We can just say x equals 93. So this is something you can do, and something that I've done in the past. It's like saying, okay, I've gotten these scores. What do I need to do on this exam to pass the class or whatever? Mainly in my my biopsych class. Like biopsychology was not a fun class for me. Hated it. Thought it was going to be really fun. Did not like. Would not recommend. And so I just did poorly in it, and I was just trying to get that C, because C's get degrees. That was my mantra on that class. Did not like it. I can understand why people do though. Okay. Any questions on that? All right. Good time. Okay. So here's another example. This is the example of why the mean is such a bad representation if there's outliers. So this fictional company, Jamazon.com, has 5 employees. Four of them make $40,000 a year. And the manager makes $200,000 a year. Fun fact, I believe, is something like managers back in like the before Reagan. It always ends up being before Reagan. But before that time period, managers were usually making on average like between like 1.5 and 2 times as much as their lowest employee. So you can see right here that be like this person is making 5 times as much. It's a lot worse than that in reality. But so $200,000 per year. So, but anyways, this is the problem. In a recent ad, Jamazon claims their average salary is $72,000. Why is this disingenuous? So this is a very, very good example. But raise this up on a massive scale of like maybe there might be another company that kind of sounds like Jamazon.com, and they might have like quite a few employees, like 1 million employees, and then their manager might be the first trillionaire in existence. And we can see a problem there. But that the reason or like solution, I guess it's not really a solution, but they're using the mean average which is greatly affected by the $200,000 outlier. The median would be a far better representation. So if you're asking for a company and and you ask them for the average salary, please make sure to say like, what's the median average salary? So that you know a very, very true representation of what their thing is. This is something like, honestly, I wish a lot more grad students knew about in different programs. Mathematicians, we know this because this is our bread and butter, but biologists might not. Like there's been several, like in a bio grad program, you usually have to do some type of research experiment. And of course you want to graduate, of course, right? You want and so sometimes people try to skew their data, like they deliberately choose the mean average instead of the median average because it looks better on the paper. But we shouldn't be trying to just do things for that. We should be trying to do them honestly. It's not honest. It's not dishonesty. It just maybe just overlooked the fact that the median average might be a better option. So like that's what I'm talking about with this whole situation is this fabricated example, but very, very accurate. You have 4 employees making 40,000. The median salary is 40,000, but the mean average is 72,000, which is, if you were applying for this job, you'd be thinking, oh, cool, I'm going to be making like somewhere around $70,000, which is not true. You'd be making probably 40,000, maybe less, maybe a little more, depending on your experience, blah, 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 blah. But either way. Any questions on that? Okay. Don't know if we'll be able to get through all of frequency tables. Let me see, like, what is our timing? Specifically, I mean, on our class. So, okay, so I was trying to get through all of it today. Let's see if I can. Frequency tables is the next concept. So, definition, a frequency table is a data table used to represent large data sets by breaking up the values based on their frequency. In the set. The frequency table, it's usually useful when you have a lot of repeated data values and there's no when there's a lot of repeated data values. So for example, I'm going to show you the data set and the corresponding the frequency table and the corresponding data set. Example. So here's the frequency table. So it has data value and then frequency. Of the two columns. And so the data values are 15. So in the vertical section here, 15, then 31, then 50, and then 86. So 15, 31, 50, and 86 are the data values. And the frequency is 2, 1, 4, and 2. 2, 1, 4, 2. So if you're reading it row by row, it's 15, 2, 31, 1, 54, and then 86, 2. So that's the frequency table. And so those numbers, the frequency is telling you how many times that data value appears in the set. So the corresponding data set is 15, 15, because there's a frequency of 2 for the 15s, 31, 50, 50, 50, 50, because the frequency of 50 is 4, and then 2 86s. That's how you break down a frequency table. This is basically very, very useful when you're talking about like, you would probably use this if you're looking at a survey, like let's say like McDonald's is running a survey or whatever, and like you rate yourself from 1 to 5 being unsatisfied to completely satisfied or whatever, you'd have a lot of ones, a lot of twos, a lot of threes, a lot of fours, a lot of fives. And instead of writing it all out as a big list, you could write it out as this one little tiny chart and then use that. So, as an example, unless there's any questions on that. The following frequency table displays the number of students in classes at an elementary school. Find the mean, median, and mode. So I'm going to draw a chart that should have 1, 2, 3, 4, 5 columns and a title column. So 6 columns in total. 3, 4, 5, 6. So the first column will be titled students. The second will be frequency. I'm going to do dashed lines for the rest. We're not going to finish this today. I know that we're going to, because the last thing we're going to talk about is GPA, which is a type of frequency chart. GPA is a type of frequency. If you've ever been curious about how they calculate your GPA, like you got an A in your English class, that's 3 credit, and you got a B in your dinosaurs class, which was a 5 credit. What's your GPA, and why is it not like a 3.5? Like a 4.0 and a B is a 3.0. So why isn't it a 3.5? It has to do with the number of credits. Yes. Yes, that's how they calculate it. So that was actually a big problem. I'll talk about it next time. But please remind me to talk about a grad school issue with GPA when we talk about it. So the number of students, I'm going to go row by row. So I'm going to do students, then frequency, students, then frequency. So students, so 14, wrong style. 14 with a frequency of 9, 17 with a frequency of 7, 21 with a frequency of 8, 26 with a frequency of 3, and 28 with a frequency of 2. To read this chart, this is kind of weird. But so this elementary school was surveyed, and so they looked through all the different classes. Apparently, this place has a lot of different classes, which makes sense actually. But this means this 14 and 9. This means there are 9 classrooms that have 14 students each. That's how you interpret, like that's how this chart works. So there's 7 classrooms that have 17 students in them. There are 8 classrooms that have 21 students, 3 classrooms that have 26, and regrettably, the last 2 are the regrettable ones. It's class sizes should be 20 at most, especially for elementary school. 20 at most. Well, once again, I don't run the world, so. Solution. So for the mean, so notice there are number of data values. This will be useful in all of our calculations. So what the corresponding data chart would look like, it would be 14, 14, 14, 14, 14, 9 times, and then 17, 7 times, and then 21, 8 times, 26, 3 times, and 28, 2 times. So the total number of data values is 9 plus 7 plus 8 plus 3 plus 2, which is 29 data values. 29 entries. If you were to list them all out and count them, you would have 29 because there's 9 plus 9 14s plus 7 17s plus 8 21s plus 3 26s and plus 2 28s. So for the mean, you could go through. It's not wrong. It's not wrong to do this, but it is very tedious. You could go 17 plus, or sorry, 14 plus 14 plus 14 plus 14 plus 14. You could do that. Or we could realize that multiplication is just iterated addition. So 2 times 5 is really 5 plus 5. So what you can do instead is it's going to be 14 times 9 plus 17 times 7 plus 21 times 8 plus 26 times 3 plus 28 times 2, all divided by 29. Because there's 29 data entries. Take the total number of numbers, add them all up. And the reason why it's 14 times 9 is, once again, there are 9 14s. So that's the same thing as 14 times 9. Granted, based on new math and common core math, it should be groups and the number of objects in each group. So it should be 9 times 14 and 7 times 17 and so on and so forth, but it doesn't matter. Which if you do this, you end up with 547 over 29, which is equal to 18.862 dot, 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 dot. We can't have 0.862 of a student. So 19 students. Not a bad mean average. Not a bad mean average. I will say, though, that this data set is probably a little skewed because there's a lot of like 14, like half the data values are already in the 14 to 17 range. And you'll see that when we look at the median. So could you imagine trying to find the median of this set by brute force? You have to list out 29 numbers, which you can do. And if this was a problem on the exam, you could do that. All right, you could go, okay, I'll write down all 29 numbers and then work my way inwards, but that's actually going to make it a lot harder. So what I would do, so number of entries equals 29. So 29 divided by 2 is 14.5. So we get one of the n.5s. So the n plus 1, the next integer above that is going to be the entry, the median. 15th is the median. So I'm going to look at this and immediately tell you that the median is equal to 17. Why? Look at it for a second, look at the chart, and see if you can understand why that's the case. The other thing I like about frequency tables is that they're already arranged from smallest to largest. Yes. Exactly right. So the thing is, the first two, there are 16 data values here. So the 15th data entry has to be in here. and the 15 data entry will be a 17. So if you were to list them all out, you write 9 14s and then 7 17s, and that would give you 16 numbers right there. And the middle number, the median number, is the 15th, and that's in that first set. Does that make sense? Let me say that one more time. So 9 plus 7 gives you, like, that's 16 of the 29 data entries. So 14, 14, 14, 14, 14, 9 times, then 17, 17, 17, 17, 7 times. That's total of 16 data entries. Our median is the 15th data entry, so it has to be a 17. Whereas let's say that it was the 16, let's say it was if the median was the 20th entry, let's just say for the sake of an argument, the 20th entry was the median. That would mean that it would be a 21 based on the entries. So, because there would be 9 plus 7, that's 16, plus 8 would be 24. So there's 24 data values, and the 17th to the 24th are all 21s. So. And last but not least, everyone's favorite, the mode. It's the simplest, especially with a frequency table. The mode is equal to 14 with a frequency of 9. '21's coming in close with a frequency of 8, but the mode is the one that has the largest frequency, so 14. Any questions on that? So that's how we use a frequency table. We'll learn next time with GPA. We'll probably do one more, we'll probably do 2 more problems. One for GPA, and then one for using another frequency table to get practice with it. But we don't have enough time we got 2 minutes. Not gonna get through that. So we'll pick up next time with this. If we don't finish 3.2, 3.3 next time, then 3.3's homework and quiz will be extended. But otherwise, that'll be it for today. If you have any questions, feel free to email me. Otherwise, I'll see you guys on Thursday. I hope to have your exams graded and handed back by then, okay? All right.